So this is my video 79 and I'm going to start it with commenting on my Swift scripts as I did before. So level 7 script, it's called digit and yeah, I solved this task in one string. Return the function square digits accepts, takes one argument of an int type and it returns int. So the whole solution is return. First I convert number of int into string, so just the string that has the same visual representation as the number. Then I do mapping of each character of this string, character in the closure, like first, again, this character is converted into the type string from the type character, and then back into the type int, and the nil coalescing operator is used to signs of question marks. This way we don't need to do force unwrapping, because this nil coalescing mark gives the pure int character, pure int number if the conversion from string into int succeeds, or it returns just 0 instead of returning this int optional, which we need to unwrap later, especially when we know that string contains the correct number from the beginning. So we have this num integer. All this first string was just to convert char into the correct digit. Then we perform the multiplication, or we have number squared, and again we convert this result into string. So for each digit of the original string, we get this digit multiplied by itself, and then we replace the original digit with this multiplication, with this result. Okay, string, yeah, and when map is performed over string, the result type is array of strings. That's why in the end we need to join all this stuff together without any delimiters, without any spaces. And again, we convert the resulting string into int using this nil coalescing operator, so that we get the number without these optionals, especially when we know that we have the correct number inside the string and the translation will be performed correctly. But there is also best practice for this task, and the first one, it uses the same initial strategy, and then they use compact map and they take character, they convert the character into string, into double, to perform this power operation, like to square the number. Then again they convert into int to remove trailing 0 character digits after dot, and again into string, and then they join this stuff and again perform this implicit forced unwrapping. And this compact map operation, it removes, as I remember, if I remember correctly, all nil stuff which is created as a result of this mapping, and then they have the array of characters or of elements which contains only non-nil elements. It means if there are some nil elements inside this array, they just skipped, and like for example, we have this string like A1, B2, C3, and so on. When odd elements are characters and even elements are digits. In this case, through this compact map operation, all the conversion of characters will be removed, and the resulting array will be smaller in size. It will be twice smaller than the original one when all the characters will be removed. And but because we know that we have the number as the initial parameter, nothing will be removed, but we don't need to do this force unwrapping or equalization operator, and everything is much more cleaner to read and to understand. So first, for the second best solution, first we convert number into the string and then into the array, of digits through this compact map, and then again the compact map is performed where each integer is multiplied by itself, converted into the string and joined, and only in the end we have this new coalescing operator. So it's much more cleaner and much more easier to read and understand this particular solution. Let me check how many Yeah, I have quite a lot of level 7. Can I do this stuff? Control A, Control A. No, it doesn't work. Maybe something like, yes, okay. I have 78 files in general of the scripts, which I comment from time to time. And let's count very quickly. So we have 78, and I have 36 files to comment. So I commented only the half of all the files. Well, I have enough information to work on. The next one is disarium number something. So again, I have a number as a parameter, the type is int, and we return the string. We convert this number into string and use plain old map, and again a new coalescing operator to get just the array of ints from the number. So basically we convert a number into the array of digits of this number. Then we go through this array. Enumerated method creates the array of pairs like index and the value of, and the digit that exists on this particular index. We just wrap each element of the array into the pair, and we add the first element of the pair, which is the index of this element. Again, we do this mapping, and this time we substitute each element with some array which is created as the as what? Okay, we have array which have the number of elements which equal to index plus 1, and each element of this array is equal to a digit, and then we reduce all this into one result by multiplying all the elements with each other. So what we do here, we substitute, we replace each digit in the array, in each element which is a digit in the array, with something, and we calculate this something like the multiplication of this particular digit by itself as many times as the index of this digit plus 1, increased by 1. And then in the end we calculate the sum of all these elements of the array, and if the resulting sum is equal to the original number, we print the Caesarium, otherwise we say it's not. And there was some quite longer solution, but it didn't use all this functional programming. So what I did in this particular solution, I just get each digit by getting the modular, by using the modular operator, and then I calculated the product of this multiplication in the loop, in the for loop, from 1 to and including the length of this number. Yeah, then I appended this product to the array, and yeah, and I switched to the next iteration by reducing the number by one element, by one digit from the end, and reducing and decreasing by one the length of this number. And in the end, I went through all the elements in this reversed array and calculated the sum. So basically I did the same stuff, but it's more verbose, and it's not, well, it works, but it's not so it's not so friendly for the reader. It's like I need to do some comments to understand what is going on without going into the code. Drying potatoes. Let's see what this. Drying potatoes. Something happens here, like we have 3 parameters of type int and 1 return parameter of type int, and we have just some particular formula which calculates the result in something like 100 subtract p0, this all over 100 subtract p1, and all this ratio is multiplied by w0. Okay. Next is easy wallpaper. We have 3 elements of type double. It looks like length, width, and height. We return some string, and we have the numbers array. The array consisting of strings which are the number of these elements, 0, 1, 2, and so on until 1920. The guard statement checks that the overall multiplication, the product of all 3 parameters is not equal to 0, which means none of these parameters is equal to 0. Otherwise, we return the first element of this numbers array, which is 0 string. Then we calculate square of walls plus extra. I don't know what it means, but somehow 1.15 times 2 times the sum L plus in open paren L plus W close paren times H. Then square of roll equals dot zero dot 52 times 10, and numbers of rows equals square of walls plus extra, over square of rows, and we round it to the closest integer, which is higher than the number that we have with the ceil operation from ceilin. Then we convert into integer, and then we return the string that corresponds to that number, like 8 or 13. Okay, so basically it was about calculating how many rolls of wallpaper we need to cover the walls of this room with some extra I don't know, extra materials. Next we have extra perfect numbers. Again, some n of integer type is taken by the function. Then we return the array of ints. So what do? We have the range 1 to 0, include 1 to n, including n, and we filter this range. When we filter it, it kind of transforms into the array, and we use each element from this range. We check that if this element is odd, then we we leave this element in the array. Otherwise we just ignore this element. We just keep this element. So in the end, for example, 1 2 3 4 5, we have the output like 1 3 5. Extra perfect numbers. All non-consecutive. The function takes the array of ints and it returns the array of tuples int. The get statement checks that the count of the array is more than 1, so we need at least 2 elements in the array, otherwise we return the empty array. Okay, then we define the resulting array, and we do this enumeration stuff, and each element of the array is transformed into the tuple index and its value. So the element at the position of this index. If the index is 0, then we just skip the iteration. Otherwise, if the difference between the element and the previous element. If this difference is not equal to 1, we append this current tuple that we process, and we continue this loop until we finish all the tuples in the array. In the end, if result is empty, which means there were no two tuples who were next to each other, and they have the difference more, and the elements of these tuples have the second elements have the difference more than 1. So then we return just empty array. Otherwise we return the array that we have. And with the best practice, this stuff do the same, the following thing. We create the array of tuples, index plus value. Then we drop first element of this array, and we filter the rest of the elements, like array, I think, index, array index, which means we check the previous element and we compare that it's not different from the next element by 1. So I have this comment like how drop first plus filter works. It looks like when I see now. Yes, when we use enumerated method over array, we create this array of tuples. When we apply drop first method, we create the array, we get the array without the first tuple. Then we do filter method over this array of tuples without the first element. But we have this reference to the original array. We get the index from the last array that we created, but we use this index to address the elements in the original array because it was not changed. It was not changed. This, now I see how this thing works so kind of perfectly. Another one, find nth digit. It takes two parameters of type int. It returns int. We have two guards. First we check that something like nth is not equal to 0 or greater than 0, otherwise we return -1 as the result of the function. And we check that the number of digits in the number which is passed into the function is greater or equal to this nth parameter, otherwise we return 0. I think nth means the like number the index, okay, of the digit inside the number which we need to get. So what we use the ternary operator, like question mark plus colon. If a number is positive, then we just, it's not, number can't be 0. Really? Yeah, if number is 0, then no, number can be 0. We just check this stuff. If number is positive, then we get number itself. If number is negative or it equals to 0, we get the opposite of this number, and minus this number means that number becomes positive. It's like I get the absolute value of this number. And then we work with this positive number. We convert it into string. We reverse all the digits in this string, and then we map. I think I should use compact map here, but maybe this particular script was created before I discovered this compact map function. So again, we have the conversion between from 0 into string, then into int. And we have, we have the element, the array of digits, which are in reversed order compared to the order of the digits inside the original number. And then finally we return nth minus 1. So it's like we get the digit at the position nth from the end, I think, of the number. It sounds quite logical. Next, something like fizz, buzz, cuckoo, clock, with a string element, with a string parameter, and the returning parameter of type string as well. We have time array, time components. Okay, the time which is of type string is the correct, oh no, it's not the correct, but it has some particular format, and we use components function over components method over string class to get the elements separated by columns. And here we use compact map to convert each element into digit. Yeah, we see here that we don't do this intermediate step of converting the element into the string and then into int, because I think components separated by function create the array of strings, not the characters. So in the end, we have the digits, the numbers that represents, I think, hours, minutes, and seconds. And we take only hours and minutes, and we create some time tuple, and we switch. We use switch operator and this pattern matching stuff with case and optionals, like if we case this as let as tuple let hours, we define the we define the variable hours. And so if we have hours and we have 0 minutes, then we do some calculations, like if hours are divided by 12 without any remainders, then we return 12. Otherwise, we return this remainder. I think we do this because we don't have I'm sure, I think we don't have this. Yeah, I'm not sure whether we have 24 hours format, but going through this statement, we convert it into 12 hours format, and then we return the array, and then we return something, which is the string, which contains words cuckoo separated from each other with a space as many times as we have this hours variable. Next, it works only for the sharp hours without any minutes. So if we have half past some particular hour, we return just cuckoo. And if we have any other minutes, then we do this interesting additional condition, like if minutes are divided by 15 without any remainders, then we return fizzbuzz. Otherwise, if minutes are divided by 3 without any remainders, we return fizz. And in the last case, we check that minutes are divided by 5 without any remainders, we return buzz. So the default action, if we have some time indication which is different from any of these 5 cases that we just checked, we just return tick, like the standard sound that this clock produces. Otherwise, we have the sound of cuckoo produced the necessary amount of times, or just one cuckoo at the time like half past any hour, or just fizz buzz at 15 minutes, at a quarter past something, or a quarter to something, and fizz for every other minute which is divided by 3, or buzz for each minute, for each other minute which is divided by 5. So, for example, we say 3 fizz, 6 fizz, 9 fizz, but 5 buzz, 10 buzz, we skip 15, 20 buzz, 25 buzz, we skip 30, 35, and so on. That's quite an interesting task. It's not very difficult, but it really uses the power of Swift as a functional language. Next, we own just the power of Swift, which was implemented inside Swift language. Then we have flatten and sort an array script. We have the template function, which works on arrays of some type T, generic type T, which conforms to a comparable protocol. So and we returns just the array of this T type T elements. What we do is we have this array, we flat map the inner arrays. I think if we have something like 1, 2, the first array, 2, 3, and the second array, 3, 4. No, 1, 2, 3, 4, 4, 5, the third array. Then flat map will produce something like 1, 2, 3, 4, 5, 6 inside one array. And then we just perform the sorting operation over these elements, and we return the array of all these elements sorted. That's why we needed the elements to conform to the comparable protocol, because we needed this sorted function to succeed, and it was only possible when we can compare some way or another two elements to order them, to change the order as we need. Functional addition. We have this function which takes some n and it returns tuple. It returns tuple or not tuple. No, maybe it's not the tuple. It's more like it returns the closure, which accepts the element of type int and returns some type int. And the result of this stuff is to use I think I'm sure what's going on. Function. For some reason we have this $0 element which we get from somewhere. I'm not sure from where, but from somewhere, and then we do this plus n operation. But my first solution was to make return and to define this number of type int, return the closure. I wrote return the closure, which takes some num of type int and returns int. And then I perform this num plus n operation, but later I deleted return and I removed this int to int type enclosure, because the compiler can can determine it itself. I just left num plus n, and then in the end, yeah, I skipped num in num, and I got the resulting example statement. Yeah, that's really difficult for me to understand. I need to refresh this later in my memory. Let's go with something simpler like movie. We have 3 parameters of type double. We return only one parameter. As usual, we return one parameter of type int. So card ticket and percent maybe. We have system A, ticket B, which is the product of ticket and percent, and system B, which is card plus ticket B. And while the system B rounded to the closest number which is higher than the number itself, so while this ceiling is greater or equal to system A, we do some calculation, like we increase times, which obviously is the counter. We add ticket to system A. We multiply ticket B by another percent, and we add ticket B to the system, and in the end we return times. Quite simple to realize and to read, but I need the original text to understand the meaning of this code. Next, invite more women is quite simple function. It takes only one parameter of type array of ints. It returns bool, and what we do is just we calculate. It's like we calculate the sum of all the elements of the array, and if this sum is greater than, and we return the comparison to 0. So whether we return true or false. If this sum is greater than 0, we return true, otherwise we return false. Next, we have this jumping number function. Takes number of type int, returns string. Okay, we do again this stuff of conversion. I convert number into the array of ints. Yes, of digits. But then I take, for some reason I define something like last number, which is the first element of the array minus 1. And then I go through the digits of the array. Oh yeah, I have this absolute value. If absolute value of the difference between the current digit and the last number is not equal to 1, we return not. Otherwise, okay, I see. And then we assign this current digit to the last number, and we return jumping. So basically, yeah, this last number in the beginning was the border with which we compare the first number, though we don't need to compare it, but in this case, the algorithm became more unified, universal, and universal. So in this particular script, we check that each digit of the number is different from the previous digit by 1. It can be like greater by 1 or less by 1, like 3, 4, 4, 3, 4, 5, 6, 6, 5, and so on. That's why it is called jumping number. Let's check this. Whoa. Okay, I'm not going into this function, into the script. It's linked lists append. Obviously, I need to read a lot of code and to remember how these linked lists are organized. And I think that's enough for today about reading the script, because it looks like I went through 11 scripts for today, and that means I have only how many? If I went through 13 scripts for today, so I think something like 23 scripts. That's all I need to go through the rest of this. Yeah, 24 files to go, but linked list scripts will be quite difficult, because they need lots of remembering of this linked list stuff. Yeah, and then it will be easy again, because the scripts will be quite short. So I will be lucky if I cover all the linked list script, which are only 4 scripts, for the next time. And I have about 5 minutes to go, so I think I'll check I'll check my Red Riding Hood poem, and I'll just read it aloud to again to check how well I can read it aloud. There was a cottage in the woods in which the girl Red Riding Hood, together with her mother, lived. At least that's how it is believed. One day her mother baked the cakes and taught the girl in red to take some extra cakes to her grandmom, residing on the distant farm. What secrets that old hag possessed to live secluded from the rest of her beloved relatives is all beyond our expertise. Red Riding Hood knew all the woods, because she'd spent her childhood tormenting animals and birds, discovering the ways to hurt without leaving any wounds, but shifting all the creatures' moods, so that at once they tried to choke themselves as she went for a walk. So it was really strange when someone wiggled in the range of 10 kilometers around her route towards her grandma's grounds. Perhaps he was a refugee, a lonely wolf on the bilgee, who didn't understand the rules. He thought that he would show these fools how they should treat the little girl. He was a stranger after all. First he collected the intel. He forced the little girl to tell what was the purpose of her walk. He showed his teeth. It made her talk. And then he rushed towards the farm. Of course, he didn't mean to harm the pigs or cows, the geese or hens. He didn't want to break the fence. He aimed to take the grandma's role. First he would swallow that egg whole, and then he'd lie down in her bed and hide his body, but his head beneath the very cozy quill. This way he wouldn't move until Red Riding Hood came to the house and checked his eyes, ears, and his mouth. And he would grab the girl at once. She'd feel his stomach for a month. And he was still lost in thoughts when he arrived to the threshold. So lost in thoughts, he never saw what that far farm was famous for. He missed the skulls on the stockade and the wallpapers which were made of all the types, of all the hides of those who could howl, roar, or bite. He rushed inside, prepared to grab. When he got stuck in some bad trap, then the enormous, heavy stout fell on his head and he passed out. He came to himself in the bed, as he'd imagined all of that, but for some reason he was tied up to the bed from all his sides. In front of him the grandma stood. She wore the apron, and some crude, large kitchen knife was in her hand. The wolf began to understand why no one tried his plan before, when he observed that all his 4 paws, which he couldn't feel at all, were nailed to the distant wall. Red Riding Hood stood with the drill in her right hand. She tried to kneel to his left side and put the bit between his ribs where it would fit. When she pierced one of his 2 lungs, she winked at him and showed her tongue. And then she made more orifices. She pierced his stomach, and the hisses came from his mouth. She drilled the spleen, intestines, kidneys, and his chin, another lung, his eyes and liver. The wolfie shook like from the fever, and finally she pierced her. And finally she pierced his heart. There were the fountains of the blood. They shot around in all directions. They reached all spots without exceptions. The walls, the ceiling and the floor, the bed, the windows and the door, they all were overlaid with blood, as if there was the bloody flood. The little girl was smeared with it, her face and hands, her legs and feet. The only thing that was the same was her Red Riding Hood. Her name derived from that Red Riding suit, but only several people knew. At first her suit was very cool. It was as white as cotton wool. But with each kill that she had made, her costume got the stains of red, and in the end it had imbibed the blood of all those ones who died. Wow, that was really, really cool. I read it without stops, without huge mistakes. I mean, not in the pronunciation, but in the mistakes of this rhyming intonation. And it's really simple to pronounce because it uses very simple words, very simple rhymes. So I'm very glad, I'm very pleased with this reading for the first time of the poem, even though I read it before and I wrote it a long time ago. Okay, let me check very quick. Yes, so this was my vlog 79, and with this I think I stop my recording because it took me the whole hour to get to this point. So this is the end.